Hello all, welcome to your channel DIY Community. Please subscribe to this channel and get access to exclusive content and resources. You will also become part of our DIY community where you can connect with like-minded individuals and receive support. Hi there. In this series so far we have seen how to set up our environments, how to download tools, and how to create our network connected components. In the previous series, we have also seen how to create our client and server applications. But we have seen asynchronous communication so far. In the synchronous communication, you send a request, your request gets blocked until it gets processed, and then the control comes back to you once it is fully processed. There is another way you can do the same thing. It is using asynchronous communication. So what is asynchronous communication? In asynchronous communication, as soon as you send a request, the control comes back to you and your request or your command get processed asynchronously. So basically it's kind of an event-driven programming. Now the decision to design your program in a synchronous or asynchronous way depends upon a lot of factors. So both methods have their own advantages and disadvantages. Asynchronous communication improves the performance of your server, but at the same time you have to be very careful about data synchronization because your server would be processing multiple clients at the same time. So let's see some examples here, how to design and how to code asynchronous calls for our server and client. So this is our server application here. Okay, yeah. So it's a very simple version of our server because our main focus is how to use this library to perform asynchronous communication. So the first class here is a session. So this particular class is going to maintain a session of our clients. Later we'll see how we can enhance this program and how we can do more complicated stuff here. So we are just building up our core components step by step. So please notice we are also using a template here, enable shade from this. So the reason we're going to discuss further once we use it. So this particular session is going to maintain a copy, or not a copy, but a reference of a socket here. And as soon as somebody starts this session, it will start reading. So it will use asynchronous call to read. So there is a lambda function here, and see we are using shade from this. So that's the reason why we were using the template there. So we want to make sure that the raw pointer from this client doesn't get destructed while asynchronous call or this particular thing is used in the lambda function. So this is the function async read sum. We are using a fixed length data here, and we are storing into a buffer. So when the read is successful, as soon as it's event driven, right? So as soon as it reads something, it is going to write back. So this is what our server is doing. It is reading some information from the client and it is writing back to the client. It's not doing anything complicated here. So basically it's echo. So this is the other function here, which is writing to the socket, and the function which we are using here is async write, and it is exactly same thing. It is writing to a socket and it is writing a fixed length. And as soon as it is done writing, again it goes back into a loop. It invokes do read, and this way this keeps running in some form of a loop. And the member objects of this session is a socket, because every session will have its own dedicated socket. So basically what happens is, as soon as a client gets connected with a server, the client and server will establish a channel, and they will have a dedicated socket where they will be reading and writing. So the next class is a server. So server is similar to what we have done before. It maintains a reference of a IO context, and it uses endpoint, which is current server's IP address and a port which we are going to configure. It initializes socket, and as soon as it initializes socket, we are invoking a function doAccept. So the doAccept will accept the connection from the client, and as soon as it accepts a connection from the client, you see that a socket gets created, and it is moving that socket to a session. So basically it's making a shared pointer of a session, and it is moving that socket which is dedicated for the client to a client session. And as soon as it does that, it returns back to doAccept, and there is another loop here. So server is basically the server is accepting connections from the client, and it is creating the session. That's all it does. And session, it will have its own loop. It will read and write, and each session will be dedicated to a specific client. It's as simple as that. It's not that complicated here. And server will have its own acceptor and sockets, and we have seen similar code in our previous programs. Now we can invoke our server by creating a reference to a context, and we can assign it a port number. And as soon as we say context run, this whole thing starts running. So this is all it is. The next one is a client. Now what client is doing? Client is also very similar to server in this case. So I wrote a very simple client here. So most of the code you have already seen in the previous examples, so I'm not going to repeat it, but very high level. We create a context, we create a socket using the reference to context, we use a resolver here to resolve the IP address and port number, which we are going to pass it as a command line argument, and it will read a line from a user and it will write to the socket. And as soon as it gets the response back, it will simply read it back. That's all. So let's compile and run our code. Oops. Okay, so one component is ready. Let's see the second component. Cool. So we will open our first window. We will run TCP server. So our server is running and it is waiting for a client connection. We can start our TCP client, and it is pointing to the server which is running on the local host with IP address 8080. So we will run two clients actually. Can do the same thing here. Right. So first client first. So first client is trying to connect to the server. It already got connected. It is sending a message. Hello from first client. Server received it and echoed back. So similarly, if this client is finishing here, but you can write in a loop, that's not that difficult. So second one is sending, hello, this is second client. Same thing. So like this, you can make your server asynchronous. I have not used loop here in the client, but you can do the same thing, and you can make it multitasking. It can serve two clients with a dedicated sockets at the same time. Thank you guys. So that's all in this video. Please let me know if you have any comments in the comment section below. Thanks for watching. Please subscribe to get more professional advice. In addition to our free online content, we also offer free online classes for students. These classes cover a range of topics and they're designed to help you enhance your skill and knowledge. We encourage you to join us and take full advantage of this opportunity to learn and grow.